Hello guys, Mr. Stoller here from your tutors. So today we're going to look into last part of grade 11, what is it, finance. And now we're going to look into additional payments and also withdrawals. So you find that sometimes when you're doing the investment, you can actually add some some money, but at the same time you can also withdraw some money at some point. Then again, also the interest also changes over time within the investment period. Or it can be a loan that you are repaying. You pay certain amounts after some time, and also again interest is also changing. So we just we need to understand how do we tackle such situations. Okay, let's get into it and see how far we can go. I want to start with questions first. So you have got questions in front of you. What do you need to do? Try them. If you don't know how to do them, this class is for you. Okay, but again, after the class, please come back. Also, I forgot to tell you guys, kindly subscribe on our YouTube channel and also follow us on YouTube, on Facebook and Instagram. Okay, let's dig in and see what is it for today. Now, Patience received a gift of 6,000 from a boyfriend. She deposited the money into a savings account. 4 years later, she received another gift of 8,000 from a boyfriend and deposited the money into the savings account. Calculate how much money will have saved 4 years after her deposit of 8,000. Assume the interest rate of the first 3 years of the savings period is 17.5% per annum compounded monthly, and it changes to 70% per annum compounded half yearly for the remaining 5 years. So what you need to understand first, you need to draw your timeline. And how do you draw your timeline? What guides you is knowing that we have got the T0 in the beginning. So where we are saying that's our T0, and how many years, you must understand how many years, because our timeline is actually determined by a year. So here we are saying how many years in total. Here we are seeing that the investment was made, the first deposit was made here, 6,000, which is here at T0. Okay, now what happened after 4 years? We have got T4. After T4 there, after T4, what was deposited again is 8,000. Okay, then this money was actually allowed to grow. So for how many years? For 4 years. So 8,000 was allowed to grow for 4 years, remember? So here it means that we have got our total of T8. Now, then what else are we also seeing is a change in percentage. Change in percentages. Now, with the change in percentages, it's what? It's the first 3 years. So we've got T3 here. On the first 3 years, we have a percentage. So we've got a percentage here, a different percent. We have got, what is it for the first 3, where we are saying the percentage here is 0, let me just use another color there, is 0,175 over, it's converted monthly, it's over 12. Now, we need to understand also the first 3 years, how do we get the total number of years? Total, the N, how do we get N? N, we say it's going to be how many years? 3 times the 12, which is going to give us 36. Okay, so our N is 36 for the first 3 years. But now, what about the remaining here? The remaining, we see that is how many years are here? It's 5 years. Remaining 5 years. So here it's compounded. It's compounded 5 years. So N is compounded quarterly here. So let's start with our I. Our I, the first one. Then the second I is equals to 0,17 over 4. Okay, it's over 4 there because it's compounded quarterly. Then our N for that whole period is going to be 5 years times 4, which is going to give us 20. Now, what I want you to understand with this kind of investments, where you are depositing differently. What guides you is the interest rate. So what guides you is a change in interest rate. So just mark change in interest rate. Then another thing again here, treat so you look at the change. Look at the change in interest rate. That's what's going to guide you. The change in the interest rate. That's what's going to guide you. And again, you must treat the deposit separately. So here, look for change. So that's what's going to guide you. So this is actually something that is going to guide you here. This is what's going to guide you. How does it guide you? Because we know that we have got 6,000 here. We need to grow 6,000. We need to grow 6,000 up until 8 years. We also need to grow 8,000 for 4 years. So what we're going to do, we're going to start with the 6,000. So when you're dealing with the 6,000 here, so let's deal with the 6,000 first. Accumulated for the 6,000. We're going to start for the first 3 years. Remember, what splits your time is your percentages. So your interest rates split, split your timeline. So let your interest rate split your timeline. So let's start here for the first 3 years. So T3 accumulated after 3 years here. Gonna be 6,000 in bracket 1 plus. Remember, we're using the formula here, which is A equals to P 1 plus I, the compound formula, the power of N. Let's see what we get there. It's gonna be plus I. Our I, we have it 0.175 over 12 to the power of 36. Okay, then let's see what we get. So that's our value there. What do you do with the value, guys? I've taught you guys how to save with the calculator. So you say shift store A. So your first value is in A. So it's 10,104,37. So it's 10,104,37. But don't need to worry about the decimals because you already have them in your calculator. Now, what about the accumulated after 8 years? Now is gonna be, because now there's a change in percentage here. A8 is gonna be equals to 6,000. Now it's 10,000. Comma 37 is now acting as our principal after the 3 years. Our principal here is gonna be 10,000. What call 10,104. Let me just write it nicely here. In bracket 1 plus our interest have changed now, which is gonna be 0.17 over 4 to the power of how many times here? It's gonna be 5 times 4. Remember, 20. So let's see what we get. What you need to do here, remember, recall A, our value, then you say times. Let's open here the bracket 1 plus 0.17 over 4. We put that there, the power of 20. Let's see what we get is 22,000. So here we're going to store again in A because we no longer need it. So it's going to be 23,229, 23,229,00, I think there, 00. It's just going to leave it like that, okay? Now, then we move on to the next one, which is for 8,000. So we are done with the what called A8 accumulated amount after 8 years for 6,000. Let's deal now with the 8,000. Now we are looking at 8,000. Okay, let's look at the accumulation there. Accumulation of 8,000. its accumulation after 8 years. How much is it? It's gonna be equal to for 8,000, let's start by having our n. That's something to note there. Our n is gonna be equals to, remember, it's 4 times 4, because this one is gonna just be 4 years from T4 to T8, so which is actually 16. So here it's gonna be 8,000 in bracket 1 plus 0.17 over 4 to the power of 16. Let's see what we get there. Let's quickly do that. 8,000 in bracket 1 plus 0.17 over 4. We do that. Let's see what we get. The power of 16. We get 15,000. So we can say shift store B. So it's 15,570. 15,570, 696566 there. Now, what you need to do now, we're going to, for the accumulated amount, how much patients we have at end of 8 years, is gonna be, we're going to add here, accumulated amount is gonna be equals to, accumulated after 8 years, gonna be accumulated for 6,000 plus accumulated for the 8,000, which we are going to say in this case here, recall our A plus recall B, then we get our final answer is 38,799.66. So it's 38,799.66. Okay, so that's how you get your final answer. Now, I hope you understand percentage guides you. Now, let's move on to the next question here. CPOS pays a deposit of 30,000 for a new car. He pays the remaining loan by paying a further 20,000 in 2 years time and 100,000 6 years thereafter. Now, interest is 18% per annum compounded monthly during the first 3 years. So with the first 3 years, the interest is 18% and 32% per annum effective, meaning to say it's compounding annually. It's compounding annually there. That's what it means for the remaining 5 years. So our N in this case here, just know that you're going to take it as it is. It's going to be just 5 years. Now, what did CPO originally pay for the car? Now, we're looking for something original value. So let's just draw the timeline so that we understand what is happening here. Okay, let's draw our timeline like that. And remember what I told you guys, you must know that we are starting from T0. And what is the total number of years here? We have got first 3 years and first remaining 5 years. So it's going to be 3 plus 5. Then we have how many? You have got 8 years. So we've got T8 there. Okay, now remember the percentages. So first 3 years we're having 80%. Then the remaining 5 we're having what? So remember here, we're going to just put T3. On T3, from T0 to T3, we have got 18%. So our I in this case here, our I is equals to 0.18 over 12. What about here? Our I in this case here is going to be equal to 0.32, just like that, because it's actually per annum, it's compounding per annum. Now, what do we need to do now? We know that we have paid accumulated amount there is actually, let's look at that, accumulated amount there is 100. Okay, 100,000. So we're having 100,000 accumulated at T8, paid after T8 there. Then you also have 20,000 paid after 2 years. So you've got, after 2 years here, we see that T2 accumulated there was actually 20,000. Okay, it's 20,000 that accumulated, because we were told that it was paid in 2 years, meaning to say whatever amount that was paid there, it accumulated to 20,000 after 2 years. So it means that, what about the 30,000? The 30,000 was deposited T0, so that one we're just gonna need it here. So it's gonna be just 30,000 deposited there. Now, how do we get now the original amount? Original amount, it means that we're going to get the principal amount for the 20,000 and also principal amount for the 100,000. So it means that here, to get the original amount, is going to be equals to 30,000 that was deposited immediately, then plus the amount that was what called the principal for the 20,000 that was paid in 2 years, then also plus the principal for the 100,000 that was paid in the last 6 years. So what you need to understand that this money grew from T0. It's something that is owed at T0, but now it's paid back in like installments. Okay. So what we see is that if we are to calculate the total amount in 2 years that was paid, it was 20,000. Then again, in the last 6 years, it was 100,000. But that 100,000 doesn't mean that we're just going to say, oh, it was just paid in the last 6 years. No. It was paid in last 6 years, but also there was a value in those after the 2 years. So after the 2 years, there was certain value of this 100,000. These 100,000 had some value. So now, how do we deal with this now? We need to calculate the principal for for the 20,000, then the principal for the 100,000. How do we do that? We know that what I've indicated in previous lectures. I think now you know our compound formula is PA is equal to P plus 1, the 1 plus I to the power of n. Now, to find our P, we're going to say A in bracket 1 plus I to the power of negative n. Okay, so it's to the power of negative n. Now, let's now see with the 20,000. Let's do with the 20,000 here. I'm just going to do for the 20,000 here. Now, how do we get the principal for the 20,000? We know that in this case here, our what is it? Our I is equals to 0.18 over 12. What about our n? Our n is 2 times 12, which is going to give us 24 because it's for 2 years. Okay. Then what is it? Accumulated amount is 20,000. So here our RA is 20. 20,000. Now let's calculate the P there. So P is going to be equals to 20,000. Bracket 1 plus, what is our I? 0.18 over 12 to the power negative 24. So that's what we get there if we have to punch in our calculator. Now, do we see what we do? Remember, you don't need to round off your answers before you reach final answer. So what do? You say store, shift, store. You can store anywhere. Let's just store in D. Okay, so we have that value in D. So we have the principal amount for the for the 20,000. Okay, now what about the 400,000? 400,000 now we want principal for the 100,000. Here we need to find the principal first for the 6 years, for the 5 years. Yeah. Wait. Yes, for 3 years. Yes, it's gonna be for 5 years here because we need the principal for 5 years here. Principal at T3. That's what we want first. Why do we need that? Because remember, there was change in the interest rate. So we need to first change. Remember, what guide us is the interest rate, and interest rate here is divided here. And we know that 100,000, we want to know what was it here at T3 before we change the interest rate. So let's do that. How do we do that? We know that our I in this case is 0.32. What about our N? Our N in this case is going to be equals to, remember this one is effective, so it's going to be just, It's going to be just 5 because it's 5 years there. Okay, so let's do that. Let's try to find out. So we're going to be saying, let's have that. So when I look at the P at T3, let's look at that as 100,000 in bracket 1 plus, what is our I? 0.32 to the power of, what is the power of? It's going to be the power of negative 5. Okay, let's find that. So this is what we get here. That our 100,000 at T3, it was 24,953.44. That's what we are seeing is there at T3. Okay. Now we want to know now how much was it at T0? That 24,000. Okay. So let's just do this. Let's just say shift store what you call E. So we know that that amount is the one that we are saying 100,000. How much was it after 3 years? It was 3 years, 5 years back. It was 24,953. Let's now find out how much was it at T0 now. At T0, which is here, so that we can be able to calculate add everything here. Now, what are we going to do at T0 there? We know that there is a change in what is it? Let's say here, let's put it there and say, okay, principal now at T0 is going to be equals to this 24,953,44 in bracket 1 plus our I is now 0,18 over 12 because the interests have changed. Remember, that's why we are doing this what called split, because of the interest that have changed. Now it's going to be up to negative what? Negative, we know that this is for 3 years. So 3 times 12 is going to give us what? So our N in this case here. So negative 36. It's going to be negative 36. Let's see how much we get then. So for this one here, we're just going to come here. We'll come there and say, okay, recall E. What is our E? And say times in bracket 1 plus 0,18 over 12 with power exponent there of negative 36. Let's see what we're getting there. 14,005. So it's just going to round off 14,600 there. So it's 14,600. 14,600. Okay, so we can just round off that. And let's just store that in what you call shift store in E again, because we have used it. You can put it anyway. Now, so now we have got this amount that we have here, and this is our principal amount for the 100,000 here. And here we've got the principal amount for the 20,000, and we have the initial deposit of 30,000. Now we can add everything together. Our original, therefore, is going to be equals to original is going to be equals to 30,000 plus the 13,999.87 plus 14,600, which is going to give us, let's do that. Let's see here, we have got the recall C, which is was it the one recall D? Yeah, that one. So here we know that we have got the recall D. We are adding it to what you call recall E, which is 14,600 plus 30,000. So we get 58,590. 58,590,88. That's our final answer. So that's how we should remember, guys, how to deal with this. That's how you deal with this. Now let's go on to the next question here. I'm just going to give you a hint on the next question, okay? Because now I think you understand now. Let's see here. Leandra deposit 4,300 into a savings account. 3 years later, she deposited a further 7,000 into a savings account. 2 years later, she withdraws 2,000. 2 years after this, she deposits a final amount of 1,000 into the account. The interest rate during the first 3 years is 13% per annum, compounded monthly. And for the remaining 4 years, the interest rate changes to 14% per annum, compounded quarterly. Calculate the future value of the savings at the end of this the 7-year period. Now, we know what we need to do. Our timeline first. So our timeline is telling us that you have T0 there and you have got T7, because here we are told that after the end of the 7-year period. Now, so, but what do we have here? We have got the deposit into the savings account, which is a T0, which is 4,300. Then 3 years later, she deposits 7,000. So we see that 3 years at T3 We have got 3,000 being added there. Then what else do we have? 2 years later, she deposits, so it's going to be a T5 now. So a T5 is minus 2,000. This is plus. This is plus. Let's put what their withdrawals now. Then 2 years after this, she deposits a final amount of 1,000. So 3 years later here, she deposits 7,000 into the account. 2 years later, she withdraws. Then 2 years after this, she deposits final amount of, so here from the T5, here is we're actually on T7. So she's adding here plus 1,000. Okay. So this was added on the final year. Now the interest rate changes in the first 3 years. It was 13% per annum compounded monthly. So first 3 years here, let's divide here. Remember what we said. The first 3 years, we've got I is equal to 0.13 is compounded monthly. It's going to be over 12. Okay. Then what is our N in the first 3 years? Our N in the first 3 years is going to be 3 times 12, which is going to be equals to 36. Okay. Now let's now see what are we supposed to do here. Want to know what is the total investment? Remember what I told you guys. Deal with these values separately. So what do we need to do? Let's look at the accumulation of 4,300 up until the 5/5 year. So we need to calculate here the growth for the 4,300. You must know what was it at here with the percentage of what? With the percentage here, and also what is it? The end there. That's what we have there. Then from there, it went further, grown for 2 years. Again, now for the extra 2 years here, what we have here, we have the change in percentage. So our I in this case here is compounded quarterly, so it's going to be 0.14 over 4. That's what we see. Then, so it means that for these 2 years here, we just are looking for 4,300 here. So it's going to be equal to our I, we have it. Then our N, in this case here, it's going to be equals to 2 times 4, because it's 2 years, but it's done quarterly. So it's going to be 2 times 4. Then it's going to be equals to 8. So we know that it's going to accumulate. Then we find the accumulated for the 20, for the, what is it? For the 4,300. Now, this 3,000, it also needs to grow for 2 years again. The 3,000 here. This is for the 3,000. It also needs to grow. Then you add the totals for what is it? For 3,000 and 4,300. You add them, then subtract the 2,000. So here you are going to say, to find your value here, the principal value here, you are going to add. So principal at T5, you are going to get it by saying accumulated amount of 4,300 plus accumulated amount of 3,000, sorry, then minus 2,000. That's how you get your principal value at T5. Then that principal value here will have to grow for the remaining 2 years. So here it will grow for how many years? For 2 years with the interest rate, which is 0.14. And here our N in this case is going to be 2 times 4 again here, which is going to be equals to what is it? 8. So here you will need to know the total that you get here. We will need to grow it for what is it? For the extra 2 years. Now, what now do you do to get the future value in this case? The future value means that the accumulated amount that you're going to get here. So accumulated amount for the T5, which is this one here, accumulated amount for the T5, which will grow here, is we are going to add it to T, to the 1,000, to get your future value. Okay, so here, remember, you are dealing with them separately. But again, after doing that, you need to add them here after where we do the withdrawal. Before you do the withdrawal, find what is accumulated, total accumulated amount. Then you take out the money, the 2,000. Then what is left, leave it to grow for 2 years. Then after growing for 2 years, you add it with 1,000. Then you know how much is it in total after the 7 years. Okay, so guys, until next time, thank you so much.